So I think you must have already like thought about why containers, why we should, why we need containers instead of VMs. We have already like been learning, trying to deploying things in VMs, but now why containers? So as you know, like in containers, instead of having multiple OSs or guest OSs, there is a single OS, and basically the things that you're running are just like processes which are being isolated and being run inside the containers, so-called containers. And basically those applications or processes have their own dependencies, and you can like pack them and run everywhere. Once you have a container, you can try to share with people and there'll be like no problems and it will run everywhere. So it allows us to like build like share those applications and have a better way of deploying stuff, right? And you can also like deploy stuff very quickly rather than VM, which takes a lot of seconds to start. It will start in seconds. And so this is where containers comes into play. So to explain how like Linux namespaces and C groups connect with whatever people are doing in cloud space, we are going to look into Docker and see how Docker uses these Linux primitives to implement containers. Okay. So before delving much deeper into this containers, we need to learn some of the terminologies that we'll have to like that I will use in this entire class. So there is these terms. Okay. So the first term that we are going to use is Docker file. So think of it as like of source code that you write, right? When you you want to run a process, what you do is first you write a .c file or something, so which is a source code file, and then after that you compile it, so which is the same as Docker file. So Docker file is some kind of instructions like code that you will write, and you will then generate an image which is like a compiled executable, and then you basically run a process, and that's what is actually the container. A running process is actually the container, and then you can also upload the images or the whatever the object file you have generated into cloud, into some repository which is known as Docker registry, and there is a Docker engine. So basically there is a daemon running in your machine which actually executes those containers, and that is the Docker engine. Okay. So I hope that you have already installed Docker in your machine, and if you have done so, I would like you to do like Docker info. Just type Docker info and see what comes out. Okay. So I am also doing it along with you. So there is two things. First, there is client and there is server. So as I said, Docker engine is basically a daemon or a server that is listening to some HTTP requests, and then it runs the containers. And the command that you have run right now, Docker info or something, is the client which is sending those HTTP requests, which is being resolved by the server. And now if you look in these informations, you will find some interesting details. For example, if you look at the server details, you will find something that is said mentioned as C group version. So there are multiple versions of C groups that is used in Linux. There is version 1 and version 2. So if you look at your information, you will find like what version of C group that your Docker is using right now. So how many of you have C group version 2? What about version 1? Okay, so there is a mix of both. Okay, so yeah, fine. You have Docker installed in your machine. So what can you do with it? So as I said, so first step is writing a code kind of thing where you will mention how to generate a basically container. So that thing is known as Docker file. So once you write a Docker file, then you can build it, and then after building it, an image is generated which is like an executable. And then after that when you run the executable, it is known as Docker container. So to better understand, let's try on our own, try to see like what is this on our own. So instead of like, for example, I can provide you an executable, right, and you can just run the executable and it will be running like a process. So like that, people have already built a lot of Docker images in the cloud, and you can, instead of building the Docker images on your own, you can pull those images and try to run those images. So one of such example is Alpine. Alpine Linux is a very small Linux that you can pull and try to run. So if you do Docker, it's like GitHub, like you clone, right? So it's like that. You do Docker pull Alpine 3.18. You will see it will pull the image, and then you can see if the image will come. Okay, let's try to do. So if you do docker pull alpine 3.18, so it will start pulling lot of things. So I think in my machine it has already been cached, so it will not take that much time. But in your machine, if you're doing it for the first time, it will take a lot of time. Then if you do now docker images, you will find the image that has been pulled right now. Yeah. So if you do, like, after you pull those images, if you do docker images, you will find the image that you have pulled right now. Okay. Now what I'd like you to do is try to inspect. So you do docker image inspect, then the name of the image. So docker image inspect. Then you'll find like lot of information that is being printed in the screen. Okay. Now this information is little bit interesting. For example, there is something you will say that there is some merge directory, upper directory, work directory kind of thing, and other things that will come back later on to see what those informations are. So okay, fine, you have loaded a image that somebody has built. Now you have the image, now you have to run those image and run it as a container. Okay, so how to do that? So you have to do docker run, and if you want to run it in your screen, then -it interactive mode, and you may give a name of the container so that it's easier for you to like do other things like stop and other things, and then give the name of the image. Okay, so the name of the image was alpine, right? So I will do is docker run -it and give a name like test or something, and maybe the image name. Now once you do that, now you are inside the container. So how do you know that you are inside container? If you do ps, which shows you, right, what processes are running in your machine, AEF for all. So there is only two processes that is in the container itself. You can see that only two processes are running, which is beansh, which has a PID of 1, and there is a PACF command that we have run, which has got like PID of 8, right? Whereas outside, if you try to see, if you do PSAF, you will find there are like lot of processes that is running in my machine right now, right? But from inside the container, it's as if there is only two processes that is running with the PID of 1 and 8. So basically you have isolated your processes in a manner that it seems as if I am the only one who is running in my machine, there is no one else. Similarly, if you try to do IPA, it will have its own interface. So everything is isolated. Okay. So this is how this Docker is running in your machine. So what you can do is, again, you from outside, like while this is running, while this container is running, what you can do is you can just go to your machine and try to do docker ps to see what is going on, and you will see that there is a container with the name of test, because I have mentioned the name as test, and it is currently running like from last 1 minute. Okay, and there is some container ID and other things. Again, now you can try to inspect this container. So I can give the container ID name, and I will have like lot of information regarding this container dumped into the screen. Now here there are like lot of interesting details that I think I should discuss. Okay, so as you all know, in your machine there are some system configuration files for DNS resolving, right, which resolves host name and other things. So those in containers, the host name is different, your DNS might be different. So therefore, those configuration files needs to be made on demand whenever your containers is being created, right? So if you inspect, if you look at it, there is some resolve conf path, host name path, host path. So those configuration files are for DNS and other things that has been made on demand when your container is running. And where is it stored? If you look properly here, you will find that it is stored in some var lib whatever. So let's try to see, let's try to cat those directory and see what is there. So you can see that it is the DNS configuration file that has been generated by Docker whenever you have created the container, right? And by default, what it is doing is in your host machine, whatever DNS resolver IP address you have, which is for my, which one was I'm using this IP address, is being reflected there. Okay. So if your Docker has some set of rules, it will change this. It might change those rules. Okay. So these are like, you can see that, okay, whenever a container is starting, it's creating its own configuration files. It is not using whatever is there in your machine. It's creating its own directory, have its own configuration files. Again, there is some overlay file system that is being used by the container. We'll come into it later on. I will discuss lot on it. And again, there is some network configurations that has been dumped here that the container is using. So all this information is there. You can try to, like, later on you can go through the entire dump that is there and try to see what means what. Okay. And now, okay, fine, at least now we have understood that somehow the Docker is using namespace to isolate your processes such that it seems that I am the only one that is running in my machine, right? But there is also this control that Docker does. Controls the resources that is being provided to the processes. Basically, the CPU or the memory that is being provided to the process is constrained in a manner that it will not take up lot of space. So how do you know, and how is it being like done? Okay. So what you can do is, if you have cgroup version 1, you can go to this folder sysfs cgroup CPU Docker and the container ID. You can do Docker PS and you will find the container ID, right, of your whatever is running. You can go there and try to see what is there. For cgroup version 2, same, the second one. Okay. So in my machine there is cgroup version 2, so I will try to use the cgroup version 2 one. So I will try to go to sysfs cgroup and then my ID was 40438 or something yet. Okay. And if I do ls, so I think sir has taught you these things yesterday, like last class. So that there is a folder in cgroup file system. Inside those cgroup file system, there are a lot of files, and using those files, you can give like how much memory you can give, the maximum memory, the maximum CPU time that a process can use to schedule its own CPU time. So those information is being done by the cgroup, right? So now these are the information that is present inside Docker that Docker is manipulating to control how much resources a container can use when it's running. So for example, maybe CPU, let's take a simple one, CPU max, let's take CPU max. So those information are the default values that is being given by Docker. So instead of you doing it, Docker is doing it for you. Okay. In the end, Docker is using the cgroups to constrain. Okay. So this is how cgroup is being used by Docker. Okay. Now you have started, yeah. Yeah. Yeah, sure. On the image or the container? Container, right? Yeah. Yeah, 43 is the identifier of the, yeah. Yeah, so this is the big identifier, like there is a big hash. So this is here, yeah. Yeah. Configuration files are being used. Yeah. Yeah. I'm going to like discuss about the file system in depth later on. Like I will. Yeah. Yes, yes. By Docker when it is run. The identifier and then the hash is same. Yeah. Yes. Yes. Yeah. Is being used to like. Yeah.
for that document.
Yes.
All the processes here will belong to that secret for control.
Yes.
If you can identify the limit, they should match.
Yeah, it should match. Yeah.
So that 43 whatever.
Yeah. Now, if you have like the container running, can you try to do RM? Try to remove the container. Docker RM and the name of the container or the ID of the container. If you try to do that, you will see that you will get some error response. It will not stop. So as you can see here, the container was running right on the first step. So I will try to, let's go here. And you will see that it will throw some error that it is running, we cannot stop it. So whenever a container is running, you cannot directly remove it. What you have to do is that there is a dependency of everything, right? So you cannot remove a image whenever there is a container. Whenever there is a container running, you cannot remove the, like, you have to do one step at a time. The reason I will come back to it. So what you have to do is you have to first stop the container, then you can remove the container thing that is there, and then only you can you will be able to remove the image. Okay, there is a dependency on it. The file system is the reason. Yeah. Yeah. So there is like states associated. In the next slide, I will be discussing about states. Container along with its whatever overlay file system it has created. So since it may have dependencies, so it does not allow you to remove unless whenever it is running. You have to first stop it so that whatever the file system is there, it's like not being used right now, then only you can delete it. So yeah, enter. Yeah, the C groups that you have created exactly. So things might, yeah. Yeah. Okay. So if I will try to stop the container, which was like test. Now you will see that the test container will stop, and whatever was running there will like stop. Will like killed. The process will be killed. Okay. And as you can see, the process here was killed. Okay. Now if you try to remove yeah, so now I have stopped, right? So what you can do is now you can try to inspect the process that was there, and you will see there is a state associated with this process here, and you can see that the status is now showing as exited. Okay, and now you can try to remove the container which was test. Now the container has been removed entirely from your machine. Now if you try to do like inspect, you will see that information is not there. It's already gone. Okay. So what's going on? So what is happening? What is this exiting and whatever? So what is going on? So there are like multiple states associated with a container. Okay. So whenever you create a container, but you have created but not started, then it has the status that is assigned to it is created. So that means it has not started, and no memory and no CPU resources have been allocated to it. Now when you try to run it, when you do docker run, then what happens is that the process is running, the resources have been given to the process, and it is currently running. And then if it exits, that means like now no memory, no CPU is being used, and this exit may happen in different scenarios. For example, you have run a application, the application has done its processing and it has exited. For example, a ML job, or maybe you are counting till 100. It has done it has exited, so naturally it can exit. Or you can manually, for example, now what I have done docker stop, right, and it has exited. So what I did was I have manually exited the docker. Or it may, like in panic situation also, it may exit. In that setup, the exit status is given. And then there is restarting status. like basically what you can do is when you run a Docker container, you can say that if it fails to, like, if it exits, don't like start it again, continue starting it again, and in that setup, basically the restarting status is given. Okay, so it will restart again and again and again. You can also pause containers, like it's like VM you can also pause VM, right? It's similarly you can also pause containers. So what will happen is that the memory will be reserved, but the CPU will not be consumed. It is like basically stopped, and again when you unpause it, again the CPU will start, like the CPU will be used by the process. And again when you do Docker RM, if you do inspect, you can see this the removing status will be there. So what you can do is whenever you run, you try to do this Docker inspect, or you can also, there is Docker stats also command, you can try to see, and it will show you what is happening, what is the status, current status of the application or the container that is running. Okay, so yeah, so we have, at least we are in a step where we have deployed a container. Okay, so what next? So what we have done now was we have pulled some image that somebody has built, right, and run it as a container. So there is something known as Docker building, but now when to build and when to pull. So the point is, if somebody, for example, you have built something and you want to share it to me, then I will pull it for, like it's normal like how we share files in via GitHub, right? And if you want to build it for yourself, then you will have to like build an image. Now this Docker building, the image building is done by a command known as Docker build. Okay, so you need to write some Docker file, and when you do Docker build, the image will build. So some of the sample Docker file looks like this. So for example, this first one is like for networking experiment. The second one is for Kubernetes network simulator. So that's like simple how things are like written. So we'll try to write a Docker file ourselves. Okay, so we need to understand some of these commands that is used inside this Docker file. So every Docker file needs a starting point, like some base from where you will take a base image, and on top of it you will write your own things that you will be using in your containers. Okay, so for example, this from can be Ubuntu, can be Python, can be Alpine, can be anything. Okay, and then there is a command copy. So you have some file that you want to copy to a image that you have like started with. So then you will use this copy. It's similar semantics with like CP and MV. Okay, and there is run command where you can use it for like doing running any command where, like for example, apt update or something you want to do, you can do using run. Okay, and whenever a application start in your like container, what should be the starting directory, what should be the working directory, you can set it up using workdir, and you can also like set an environment variable using env. So now there is two things here. So there is an entry point and there is CMD. So these are, you can use both of them to execute, like what is the first thing that you want to run in your machine. Okay, the difference is that entry point by default is bash. Okay, if you don't specify anything, it is bash. Now CMD is the thing that you want to run. For example, you want to run PS or iperf or any application. What happens is that to entry point the command is given. It's like to bash you are giving the iperf command that you run iperf, because shell will do it. But if you don't want to use bash, you want to use ZSH, then what you will do, you will change the entry point to ZSH, and then in command whatever you want to do, you can do the executable and whatever arguments you have, you give and it will run. Okay, so let's try to build our own Docker file. Okay, so I think you all have idea of what is Flask. It's a Python library which allows you to like maybe you will go to the route and it will return something. Okay, so here is a simple example. You can download those hello.py file. I have already uploaded in my like website. You can download it, or you can write it from scratch also. So basically what it does is you can like go to / and in the browser you will find like you will see hello world. Now this is a one application that you have written, right? And you want to build a image which will run in container, and you want to have this application accessible from your machine anywhere. It can be from your phone, for whatever. So how to do it? So I hope that you have written this. If you want me to wait, I will wait. Just Go to my website. This you will find.
I don't know. I don't think anybody knows what was Flask.
Yeah. So let me just go through Flask. Okay.
Flask is basically just a wrapper to create
Yeah.
and it based on the URL that you provide in your service, you can switch to a custom. In this case, for example, app.route slash says that you can specify with a slash, which is just the base URL. It will switch to a function called hello and then return hello world.
Hello world. Yes.
So basically, the idea of Flask is to deploy functions on the network. So you write your own functions, and if somebody has to access the function on the network, you need to write a network wrapper around it. So Flask automatically does that. So if you write this code, you should be able to access hello world via a browser.
Yeah.
That's the idea of this.
Okay.
The container intersection with this is we want to run this application within a container. That's the idea. So this hello.py is a program that you want to run within a.
Okay.
Just look at this
WSL. Yeah. I think it will work. But you don't have Linux. Okay. You have downloaded the script, right?
This program is hello.py.
Hello.py. Yeah. So you have this hello.py file, right? Okay. So think about it like this: that you have written a Python script. You want to run a Python script in your machine. What will you do? Think that you have a scratch Ubuntu machine installed in your like system, and you want to run this Python file. What will you do? First thing that you will do is you will install the app dependencies, right? First you will require Python 3. You will require the library, the Flask library. This is the first thing that you will do. So how regarding, like I have already discussed, right? What are the commands that you will use, like that is available for Docker file. So what will be what will write here after? Like in how do you install app dependencies? Yeah, sudo apt install. But how will you write it in here in the Docker file? How will you write it? Yeah. Okay, so I'm showing you. So what is happening whenever you are doing update, then you are using Python, pip, and then you are installing Flask. Then the second step is you have to copy the file that you have written in your directory from the host to the inside the container. So that is copy hello.py to root directory, and then you are setting a environment variable and running the command Flask run. So the Flask is basically the executable name, and then other things are like the arguments that you pass, right? And once you write this Docker file, then you can build your own image. Okay. Yeah, but the question is, do you think this? Yeah, this will run, but from outside the container, will you be able to access this Flask application? Yes or no? Yeah, so by default, Docker does not allow you to access its own network from outside that container. So if you want to access the network from outside, you'll have to expose. So where is the Flask application running? In the port 8000, right? So you will also have to expose the port 8000 to say that, hey, from outside, I'm exposing 8000. From outside, you can use these ports. Other ports you cannot access. Okay. What does that mean?
You expose a port, you access what is happening?
So basically, I'm saying that my 8000 port can be accessed by outside.
Outside, if I access 8000.
No. There is a way to do it. I'm saying. So this is, you are exposing in the image. You are saying that 8000 can be accessed from outside. Other ports will not be accessed. But how do you access? That is the like next part. Okay. Again, the Docker file is there in my website. You can download it. I will just go ahead with next step. So what you can do is, now if you have the Docker file, now you want to build the image, right? So what I will do is, so here I have the Docker file. Let me just show you the same thing. I have the same thing here. Okay. So what I will do is Docker build -t, and I will give a name, maybe hello 695, and I will give a tag. It can be version name, like version 0.1, anything. It can be latest also, and then dot, specifying that this is the directory where there is a Docker file from where I want to build a Docker image, right? if you do that, it will start like usually it will take a lot of time if you're running it for the first time, because it is going to pull lot of things from the internet. But I have already used it, so that's why it is like quick, very quick. For the layers, it is going to pull everything that you have written in the Docker file, right? Things like from Ubuntu. So basically it will pull the Ubuntu from there. When you do the sudo apt update, it is going to run sudo apt update. When you are installing like apt-get install python 3, it's going to install python 3. So but since I have everything, I have already run it in my machine, the Docker has already cached those files in somewhere, and it is reusing those files. That's why it is so fast. Yeah. I ran docker build -t, the name of the image that I want to like use, and then tag, basically it's like versioning, and then dot specifying that this is the folder where docker file exists, the path for the docker file. Okay, and once you do that, what you will see that when you do docker images, you will find a like image that you have just created on your own, like whatever you have done, right? So it's there is a docker image for it. Yeah, sure. Which one? This one or that one? What task folder? Yeah.
It's not linked to this. You can check the whole URL back. There's no link to it on the web.
There is no link.
Link to this file on the web page. You have to put in the whole.
I think it should work. Then yeah, it's working. It downloaded. It has downloaded. It's working. Huh? Okay, just so this is the so this was stored somewhere else. Let me just
You can just give that repository slash file and all the files.
so this is the URL for the Docker file. Okay, and for other things you need to go there. Here inside this folder there was like app.py thing. Hello.py, yeah.
Why not then we can just make the directory readable? All the files are in the directory. Just go to slash p.
I don't think if that's possible. It's not, I don't know. I think it's not. Yeah. So now if you have the image ready, so how do you make an image? Is like docker build then -t test and the image will be there, right? So once you have the image, you can now run the image. So now I was saying something, right? You have exposed some port, right? The port was 8000 and you want to access it from your own machine. So you will have to map something from inside the container to outside. So what I'm doing here is that, so this is the command that I'm running, docker run -p. Then there is a local, so this is localhost specifying that in my machine this is 127.0.0.1 is what I want to access, and my port number is 8000. So my port number is being mapped with port number of 8000 inside the container. Okay. So basically the second 8000 is off inside the container, and the first one is basically specifying in your machine what is the port number where you want to map this. So now if you run this, if you try to run this docker run minus maybe, okay, I'm running it directly, and 8000 127.0.0, it's there. The image name is Hello695. Yeah. So basically what I did was I ran the image. Now it's a container now, and it has mapped the internal port of 8000 with the external port of 8000. And now if you try to curl in your machine in 8000, you will be able to access whatever is there inside your container. Okay. So let's try to do that and see what happens. So curl localhost 8000, and you can see that the function that we have wrote in the Flask file is being reflected here. It is returning hello world every time like we are trying to do a curl or sending a HTTP GET request. So if you open it via browser also, you will find this hello world printed in your screen. Okay. Yeah.
Can we,
Hmm.
can we specify configuration in some configuration? We have to run the command like if this port should be matched to this port. Can we?
Yeah, you can do that. Yeah.
In the Docker file, the third step, speaking to class.
Yeah.
Somewhere like externally managed environment cannot install
Which one?
the third one, speaking to class.
Yeah.
Externally managed environment cannot run it inside the image.
So from what Ubuntu you are using? 22.04 is it? Yeah, the latest does not have, like, it does not allow this without virtual environment. So that's the issue. Use 22.04. Otherwise you will have to use something UV or something tools to make sure that it works, like ppex or something. Yeah. Okay. So as you have seen that we were able to like take application, run it inside container, and it was working fine, right? And again, so now you have built a image in your own image, right? You can try to like push it to a repository and give it to people. Say that I have made a image. You can pull and try to run it on your on other people's machine. Okay, so that's something that you can try out later on because it requires some Docker Hub account to use it. Okay, so what if instead of writing is docker run -it whatever I have written, what if you want to do it programmatically? Instead of doing this, you want to do it programmatically. You will maybe you don't want to run one container, you want to run 10 containers, 11 containers. So how do you do it? So this is where Docker Compose comes into play. So it's a tool where you can define multiple containers, and once you write this, like there is a YAML file that you have to write, and once you define that, you can run many containers at the same time, and there are a lot of things that you can do with Docker Compose. Okay, so let's try it out on our own. So can you go to this website and download whatever the tar file that you have? Please download it, untar it, and you will find lot of things inside it. So what I will try to do here is that earlier step we tried to run a single container, right? Now I will try to run multiple containers and try to communicate with each other. Okay, so what is going to happen is that, and one interesting thing about this Docker Compose is that in a Docker, if you are creating multiple containers via a Docker Compose, they have a common network namespace. So basically the containers will be able to communicate with each other. Okay, so let's try to do this. So if you untar the folder, so if you do like this using Docker commands, like Docker build, you are building an image and you are creating a new container, they will not be able to communicate with each other. You will have to add many things to communicate. But Docker Compose creates containers in common shared namespace, and you will be able to communicate. Okay. Now first thing that I want to show you this. Basically there is this Python application, again Flask, but here I am also using Redis. So Redis is a database, simple database that we are using, and if you try to use Redis, you can do it via network. Like you can go and do HTTP request to Redis server, and Redis server will return something that you can use it in your own application. So, and this is a very simple application that is like every time you hit the URL, it will keep a count of how many times you have hit it. So like 1 time, 2 time, 3 time, and this count 1, 2, 3, how many count you have hit this server will be stored inside the Redis server. Okay, and this communication to the Redis server will happen via this line. As you can see, there is a Redis in port 6379. So in the container namespace, in port 6379, the Redis server will be running. Okay, and now you are running this Flask application, and it's now on your like Docker file. You can define whatever port you want to expose this Flask application to. Okay, so this is the application file, and there is this Docker file, and as you can see, this Docker file is only building the application, like uh, the Flask application. It is only running the Flask application. Other Redis kind of thing we are not doing at all. We are not thinking about Redis at all. Okay. And there is this requirements.txt file that has like that we are saying that Flask we need in Python, we need Flask and Redis. Okay. And if you now look at the compose.yaml file, so this is where everything comes into play. So we are defining two containers. So the first container is web container, which is the Flask container, and there is another container, Redis container, which is the database. And we are saying that we will use the image that has already been built. We are not going to build it on our own. We'll use whatever image is there. And in case of our web container, we'll use the Docker file that was present there. We'll build the Docker file and use it. And we are exposing 5000 was the port. If you look at this Docker file, you will find that we were exposing the 5000 port. So we will be mapping this 5000 port with 8000. You have asked the question, right? Can we write it in a file? Yes, you can write it in a file in this file. In this file, you can specify what ports you want to map, and then if you have this file ready, what you can do is you just do docker compose up. Now once you do it, what it will do is it will first pull the Redis server. Yeah, the Redis image is pulled. Now it will try to build. Yeah. Okay. What happened? Okay, so I am already running something. So already 8000 port was binded. That's why I was not able to map it. So I need to close it first. Docker stop. And the name is, I think it's already stopped or what? Hello Cs695 Docker rm no such container. How do I make it smaller? Okay. Still running. Hello Cs695 latest. Yeah. Confident Chatterjee. Yeah. Okay. Now if I try to do Docker compose up, as you can see, basically now instead of one container running, there should be two containers running, right? So let me do Docker ps from here. And as you can see, there are like two containers that is running. One is compose web, which is actually exposing, and there is this Redis server that is storing the count, right? Now if you try to do curl localhost 8000, you can see that it is saying that hello world I have seen one time. Again you will see that this number 1, 2, 3, 4 is coming from a different container, and the output that is coming is from the CSE compose web container. Okay, so this is how you can use Docker Compose to like build more advanced and like very intricate applications. Okay. Yeah. So this is the
So in a way, do we need to specify the name of the Docker file because we may have multiple Docker files in a directory and
no, you have to specify. Yeah, if you have multiple Docker files, then you will have to specify. But if you have only one Docker file, you can just specify dot, and it will just consider that Docker file only. Yeah. Sorry.
how two containers are running, which two containers are running.
So when you specify this Docker Compose file, right, you are specifying two containers. The first container is this one. The second container is this one. So this is one container that is one is using the Docker file, and another one is using some image that is already been hosted. Okay. Because they have a common network namespace. So this is inside container. This is outside container.
Here it is already DHCP is already configured by Docker, or how IPs are given to those two containers.
Those two come, yeah. So there is a Docker is configuring everything for those containers. Yeah, it has inbuilt networking support for allocating those informations. I think 192 something maybe, or something. Yeah, you can actually do Docker inspect and try to like, let me do Docker PS first, and Docker inspect and maybe F7, and you will see that there is this IP address and other things that is present here. In the inspect, you will find all the information that is there, and you can like try to see. So this allocation is being done by Docker only. Okay. Yeah, within a container. So, but they both of them have a same like common network namespace. Other things are isolated, but the network namespace is like common.
Also, in that, how did you expose the for the Redis vulnerability?
Redis is a default port number that it uses, and we are using that only. For the Flask, we are exposing the port 5000. Like Redis is a generalized port that it uses.
So, what are the internal and the external ports for the Redis container?
So basically, it's something like this. So this is container namespace, this is host namespace, okay, and there is a Redis application that is running here, and it is running at 63498 or something.
So, this is the port within the port number within the container.
Yeah, so this is let us consider namespace maybe NS1, okay, and this is container, this is Redis container, okay, and there is another container which is the web container. It has like 5000 port number, okay. Now they both share a same namespace. Since they both share a same namespace, if you communicate using local 6349, you will be accessible.
Because you are not communicating to the Redis one from outside.
Yeah, you are communicating with your own machine. So using localhost, you will be able to communicate. But from your host namespace, you will not be able to communicate at all initially. But once you set up this 8000 mapping, what is going to happen is that there will be some bridge here, and that bridge will connect your 8000 with your 5000. So whenever you try to like curl like 8000 here, it will go from bridge, go to this 5000, and it will pull everything from here. And internally this 5000 will communicate with this 6349 and pull the number like how much, so 1, 2, 3, 4, whatever number is there, it is going to do that. Okay.
Expose 5000 is for the web container.
Yeah, for the web container. So 5000
Expose 6349 would have been
will be
in the image that created the Redis image file.
yeah.
But since you're not deploying Redis from an image from a Docker file, we are downloading the image directly. The image is already pre-built with something which has exposed 6349.
Yes.
Just use the image, we can talk to it.
Yes.
8000 is exposed to be accessed from the host namespace. But 6349 is intended to be accessed from the same namespace.
Yeah.
Does it need to expose that?
No, it is, they are not exposing it.
Expose is just saying that that code is available to be accessed inside the namespace.
Inside the namespace, you are not.
The container, this code is available.
Yeah, so there is two steps, right? One is exposing and another one is mapping. So basically here in the bridge you need to map port number. So that mapping is done here. So you are specifying ports where you are saying 8000, 5000 and the mapping is here, happening here basically. But for other 6349, have you specified some map? No. So basically it will, you cannot access until unless you will give this information to the Docker saying that I want to map this with this. Okay?
8000 is the host port number. 5000 is the container's export port. So if there is 5000 not exposed, you can't map 8000 to it.
Yeah.
So basically, when I specify multiple containers within the same Docker compose, we create the same namespace for all those containers.
Yes.
Network namespace is one.
Yeah, network namespace will be common, but other things will be not common. Other things will be shared, different.
But if there are two, I want to create two containers which both of them needs their own separate Docker file to build.
Yeah,
In that situation, what will it be the Docker file?
you will also add build here, another build here.
No, like the name will be the first file name, like Docker file 1, Docker file 2.
You can specify different Docker file name also here. Docker file is a generic term that you are using. Like for example, what I did was I used Docker compose up, right? Docker compose up. I did not specify any file name.
Docker compose will directly call the Docker compose.iml file.
Yeah, because it is a generic term that is used, right? If there in directory, if there are different names, you will need to specify what file you are using. Similarly, you have multiple. If you have multiple Docker files in your directory, you will have to specify. But a generic term that is used everywhere is Docker file. So if you have Docker file there, no need to specify what is the file. Just give dot, and it will automatically search it for you. So that's some short circuiting that they are doing. It's not very.
I ran the container and then I made some changes in the file system. I made some changes in the configuration of the inside the Docker. Let's say I changed the host name or environment variable or something like that. I stopped the container. I started it.
You will have to build again. You have to build the image again before starting.
Just starting the container. I'm not building it.
No, then nothing will happen. You will be
I
changing.
get the change the configurations.
So see, I'm coming to the file systems. Then I will you will understand more what So containers are not stateful. So if you have done any changes in the containers and you have closed it, it's gone. It's not there. So let me come there. I will come back. Yeah.
This like IT server class server communicates to 6349. Is it via namespace or via the base?
So it is bang. So if you have namespace is basically, again I will should demonstrate what is namespace properly and you will understand what's going on there. Basically this is trying to do localhost 6349 and here we are trying localhost 8000, but these two are different namespace. So
6349 of Redis would be reached to 6349 in the official image.
sorry.
In the official image of Redis, 6349 in Docker image is reached to 6349 of host namespace.
No. So again, mapping is different, expose is different.
So which ports if a container exposes a port or a port number, you can use the port number for something to listen into the container. That's what expose means. If you are not exposing any port number, you can't reach a container at all. Mapping is saying which port number of the host you map to an exposed port number in the container. So if you do 12770 or 8000, you are actually accessing 5000 in the container. So that is mapping.
So basically this is port forwarding. Okay.
So in the Redis container in this example, 6349 is an exposed port. 127.0.0/64. You do that, that will hit the port number of the host machine.
Yeah.
Nobody is listening to, nothing will happen.
When I will explain net, because if I complete it in 20 minutes everything, you will understand. And if you continue the discussion, then you will not understand everything. So let me complete, then we can have lot of discussion.
So the other question is that Docker file. Docker file is just a name. You can call it whatever you want.
Yeah.
By default, it's called with multiple Docker files, you just name them in that file and it will.
So if you do Docker compose up, then everything is running interactive in interactive mode. So if you want to close, you have to do Control C. So what if you don't want to do that? You want to detach and run. So there is this another alternative options that you can use. First, let it like stop the containers that is running. Okay. So while you do compose up, what you can do is you can just pass on a flag here -d saying that detach, don't run it in interactive mode. Now in background it is running, and you can use curl and whatever, and then it should work as usual. As usual it is working. And now when you want to stop the Docker compose, you will have to do like Docker compose down, and on the containers will be stopped. Again, it will take some time. Let it be. Oh.
Same for the compose file also, like Docker compose, we are not mentioning the name of the file.
Yeah, same.
So it will search in that same directory and
Yeah. So you can search for what are the like common names that is used for Docker compose and Docker file. You will find it. Okay. So we have made images, on our own, pulled images, ran container, and done many things. So one thing that you might have noticed is that if you don't have the image in your machine, then it takes a lot of time. But once you have the images, it takes it doesn't take any time. It starts as soon as possible. But how is this working out? So one of the important characteristics of Docker that Docker implements is basically layers. So what happens is that whatever you have written in the Docker file creates a layer. So every change in the file system, so basically every command in the Docker file that changes the file system is known as a new layer. Okay, and it captures the diff from the previous layer, so that you can share those layers across multiple containers or multiple images. Okay, so yeah, take this example. So do you think the first one is a layer? Yeah, so it's downloading something. Earlier it was nothing, you have downloaded something. Okay, so this is a layer. So the second one, will this be a layer? Yes, because it's downloading something. Next one, yes, definitely it will be. The third one, now you are copying a file, right? So this will also be a layer. You are removing a file, this is also be a layer. The next one will this be a layer? No, it will not be a layer. So it's a metadata that is stored to specify to the container. So when a container runs, this is some metadata that this is the environment variable that you need to use. Similarly, the expose and other things are not layers. Only layers are the initial 5 steps. Okay. Now, what this Docker does is that every step they consider, they download this everything and put it in a file system, and they say that this is the layer, and next step they download and put it in a folder. Now, if there is another Docker file that you have written that uses the same Ubuntu or Alpine, it will not download, it will use those layer. Okay, and whenever you do a change, you create a new layer and then you change it. So basically what they are doing is that you have downloaded layer, okay, and maybe there is a container and there is a B container, both are using this common layer. Okay, so what they will do is they will make this layer as read protected and apply copy on write here. So unless until you are trying to, reading is fine. So when you try to write this layer, they will perform a copy and pull it in their own layer and do a change here. So this is how they are optimizing memory. So multiple containers, if they are using same thing, so maybe you have started this whatever hello Cs695 or hello.py, whatever container you have written. If you run 5 of them together, they will all be using a same files that is there. So they will not create multiple directories. So if you think about it, if you use VMs, they will take lot of space, right? They will take separate space that you need to allocate. But here what you are doing, you are sharing those things and only changing whenever you try to write on it using copy on write functionality. So this is how optimization is working here. Okay. So again, how is things working? Layers. Everything is layers. So each of these commands that you are doing makes up layer, and then on top of it, the difference is stored, and you access those things, right? Okay. So let's try to do this. So the Docker file, you already have the Docker file. We'll try to build it, and we'll try to see what is there. Now one interesting thing is that for the, let me just open and see. Okay. How many layers are there in this Docker file? 4 layers. 1, 2, 3, 4. 4 layers are there, right? So there will be like 4 layers in the image. In the image there will be like 4 layers. For when you will run the container, so how many layers should be there? 5. 1 for the container, 4 for the image. Okay. So let's try to see what happens now. Docker images. Yeah, I have already hello CS695 here. So let's inspect hello CS695, and here you can see. So again I will come back here. Okay, all the files, these layers are actually stored in this folder where live docker overlay 2. This is the folder where all these layers are stored as a directory. Okay, and these directories have multiple subdirectories. Okay, each of them have their own semantics. So diff is the difference in the layer. Okay, then there is link for short name of the basically the file system. Okay, and then there is lower, which refers to parent. So if it's the first layer, then it will not have a parent, definitely. So it will not have lower directory. Okay, then there is work, which is internally used by overlay file system, and there is a merged, which gives overview of, like, it will take all the differences and everything and it will create a new view, and once you look into the view you will see all the files, including the differences. Okay, so now here if you look at it, there is this lower directory, and as you can see there is like how many should be there. We wrote 4, right? There should be 4. So this first done, then from here you see second, from here you see third, and in the upper directory 4. Yeah. So this the lowest directory is this one. This is the first layer where the, so not this one, from this one, where this is the first directory, first lowest directory, right? The first step from Ubuntu. Then this is the next step. Here sudo apt update sudo apt install python 3. So this is where the difference will be there. Then the next step here, what was this? Sudo apt install flask, and the last one, this is where the copy hello.py should be there. So let's see if it's true. I will copy this one and I will cd to the directory and I will do ls. As you can see, this is Ubuntu 22. So the entire directory of Ubuntu 22 is there in this diff. And as I said, the first layer, basically the lowest layer, will not have basically, if you do cd // sudo su, it does not have basically lower because it does not have any parent. It's the first, therefore there is no lower. And what is this link? Interesting thing, right? What is this link? So it is a short name for the entire like big name of this directory, because when you try to mount, so internally what needs to happen? You need to take this directory and mount in your machine or container, for the container, but while you are mounting, the name cannot be very big. So what Docker does is that it creates a shorter name and creates a link, soft link for that folder, and while mounting it uses those short names for mounting. Okay, and it basically refers to this. So the first layer is the first layer's diff contains all this Ubuntu file, right? Let's go to the next layer. And so as you can see, this is the difference. So basically when you do sudo apt update and install Python 3, they have modified these files and only those difference files are there. Okay. And the next one. So this is for installing the Flask. So again, some things have been modified in this. And the last layer where we have copied the hello.py. Okay. So this is the last layer. So there is hello.py. So these are the 4 layers. So every command that you are using is creating a new layer. Okay. Now let's try to run and see what happens. Okay. Merged is present only for the containers, not for the image. Okay. Because images have only directories. The container sees the overview of all those changes. Okay. So again, lower directory basically all the parents, differences of all the parents. Upper directory represents whatever is there, image, final image differences will be here. And now let's try to see what happens in the container when we run the container. So again we'll try to run docker run, not here, maybe here, docker run -p. Okay, so I have started the container. Now if I try to inspect docker ps, so there is affectionate Stonebaker. Sorry? Yeah. So if you come look here, the first thing that I want to show is that you need to do mount slash grep mount grep overlay. So as you can see, I didn't show earlier, when the container was not running, there was no overlay file system that was mounted. But now when the container is running, what it is doing is that the merged directory that contains all the differences is taken, and then they are mounting it, saying that use this for the container. So this is where the chroot happens. When you run the container, a chroot needs to happen which considers it, okay, this is the root directory of my container, right? So this is where the root directory is, and it is also mentioning that this directory is read write. So it's a read write access. You have this read write access, and this is how things going to work. Okay.
What is the temporary directory? So it's
Sorry.
one day directory is the temporary directory because
No, it's a not trend. It's a basically you have access to write. For in other layers you cannot go and write.
what you were saying containers are temporary, whatever changes you make.
Yeah. So that's the point here. So once you these are whenever it runs, it puts files here. Once you stop, things are gone.
One day directory is
Yeah. So this upper one. So there are many layers, right? So So there are many layers here, as you can see. So the lower one is actually the layers for the images. Those will be there. It will be never gone. But the upper layer, which is the container layer, where there is read write access, where you can do whatever you are doing in the runtime. So these will be gone when you stop the container. Okay. So now let's try to see the merged directory, because the upper directories are common, right? So as you can see, it's creating all those directories. So there will be 5. All those directories are here, and there is a new merged directory that it has created. Now if you look at this merged directory and you do ls, you will see everything. We copied hello.py, right, in the root folder. You can see there is hello.py in the root folder. This is where the chroot happened, and you started using basically this directory to do that. Okay. So this is how this overlay file system works. But basically, what is overlay file system? That's what we want to understand. I think I have missed something. Yeah. So it's a basically union file system. It takes many files, many directories, and on top of it builds and says, hey, this is a directory. And internally it uses files, and it can be run on top of XFS file system, or it can be on top of ext4 file system. So when you do docker help, I think docker info, you can see in my machine I am using overlay 2. So I am using overlay and it is using internally what it is using? It is using ext4. So on top of ext4 journaling system, it is basically doing this overlay file system. Okay. So if you are using some different file system, maybe it will show here. And now let's try to understand. So this is the overview of what is happening here, right? So there is a upper directory, lower directory. So all the lower directories are differences from the images. There is upper directory which is your container wala thing, and there is a merge directory where the ch root happens. It takes all the things together. Okay, a combined view of everything.
But how merging happens? We need to know what is the remove, what is the added.
So that is the driver. This basically there is a overlay user space, overlay file driver that is doing all those things.
But we need to store that information also, right?
So that is internally handled by Docker overlay file system driver.
So does this upper, like the first layer, does it make a new copy or does it just
I'm coming here. So now let's try to understand how operations are being done here. Okay, so you want to read file. Okay, so there can be three scenarios here. So first scenario is it does not it is not present in the container layer. It is present in the lower directories. Then what you will have to do is you will have to like read from the lower directories. It is very low overhead because you are not copying anything. You are just reading from. But the point is you will have to find where is the directory present. You will have to find. So that because due to that there is a little bit of overhead that gets added. There is other thing is that it is present in the container layer. Then you can directly read from here. No overhead, right? And there can be scenario where that file is present both in container layer and image layer. Then you will always go for the container layer and try to read those things. Okay. Now here is the problem. Like file write. What will you do in the file write? So if you are doing file write for the first time, okay, then copy on write happens. What you do is you will have to copy the file and then modify it, right? And for the first time, then afterwards it is going to use their own container layer file to update whatever you want to do. But overlay file system works on file level. So what is the catch? What is the implication here? It does not work on block level.
So if the file is very huge and if you are changing only small bit of information, it will copy the whole file.
Exactly. So that is the problem. So if in your while you are using this container, if you are like copying lot of files, it will be very slow because you will be doing copy on write again and again and again. Okay. And another problem is that if you have written a Docker file in a manner that it has multiple layers, many layers, then you will have to find where is the file present. So it can be also give a low performance here, overhead here. Another thing is that file write is fine. Then file delete. What you do in file delete? Because you cannot delete, that is like underneath, right? You cannot go and delete anything in the basically image layer. So what you do is if you want to delete a file, you give a dummy file there and say this file has been deleted, whereas files are there in the image layer. So if you write bad Docker file that has taken lot of things and in the runtime you are deleting stuff, it's the size, so the storage will never be decreased. It will be there, the entire storage will be there. You have not written a good efficient Docker file basically. And similarly for directory also, you will have to like add a dummy opaque directory which does not have anything. And renaming directory is possible. So basically, renaming directory is not possible. You cannot go and rename directory, it throws error. You cannot go and change like /bin to something else. Docker does not allow it, okay. And so this is overlay file system that is being used by default. There are like other file system also like BTRFS, which internally uses block level operations instead of like file operations. And again, for scenarios where you have lot of copies, you might use that and you will get better performance here. So this is where overlay file system is done.
Basically, in a Docker container, we cannot change the name of any directory.
Any directory? No, you can change your directory, but any directory that is present in the image layer, you cannot change. While you are creating the image, right? In Docker build, you are creating image. After building, if you go in and try to change directories, it will show you error. Yeah.
By image layer, do you mean the lower level?
Sorry? Lower level?
By image layer directories, you mean the
Lower level, yes. Yeah. Because if you try to change the lower level, the dependencies mess up.
Why is that a constraint? Similarly, we can do this. whatever we are doing for a delete, like we are marking that file as deleted, we can also do for a rename as well, and we can say that this name of this particular directory change. We can store some metadata regarding it, and we can simulate that directory is already
I exactly don't know what is the like problem here. Renaming.
The lower levels have been shared across containers, so you can't really delete.
Yeah, so that's one of the reason. But exactly, he's trying to say that in the read write layer we'll modify, we'll put these things and it should work. Yeah, but I don't like, it is not possible. Why? I need to look into deep like. Okay, so we have understood how file system works, how it has been optimized, and why it is so fast, why Docker is good. Okay,